choices within these categories, and how do I determine what may be the best choice within that particular category for my operation? In other words, how do I get the best bang for the buck? So what we'll be covering today topically is we're going to discuss the operational drivers, efficiency, reliability, and safety, and then within that, their impact areas that would be associated with each, and then the possible remedies or solutions to consider once you've found that area, and then how do I prioritize it in the very end? Okay, so the main operational drivers for today's discussion are efficiency, reliability, and safety. All areas that I've discussed in the past, but never from this perspective, and I think as such, it's going to shed a totally different light. For instance, where do the problems with these drivers normally lie? And once found, what are the most popular solutions within that area? And then finally, what's the suggestion for prioritizing the fix if a few solutions exist, or maybe I'm competing with other departments to get the appropriate capital funding? So let's start with efficiency and including both fuel and electricity and how that's consumed and applied to the boiler and its support equipment. And those of you who have attended my webinars in the past have seen so often that fuel and electrical energy play such a big role in the overall cost of operation in virtually all energy plant facilities, as depicted here with the red arrows, and totaling well over 50% of the total operational cost. All right, then when considering saving energy, where are the impact areas? Well, we'll start by acknowledging the most popular fuel burned today, as you all know, in our boilers, is natural gas. However, when looking at fuels, it's also very important to understand their relationship in terms of their respective hydrogen-carbon ratios, as you see here in these bar graphs. Note, too, the amount of carbon is the smallest with natural gas, meaning it has the lowest amount of carbon dioxide generation, which, of course, is of great importance to the environmentalists. But from an efficiency standpoint, it also contains the greatest amount of hydrogen. And then when combining with the combustion oxygen, the greatest amount of moisture generation, thereby netting an innate loss. So, it behooves us to burn this natural gas as efficiently as possible. And, one of the top areas for scrutiny is how the fuel and air in the burner are being controlled, and what kind of shape is this fuel and air metering system in. For instance, as you can see here, it's a single point positioning system wherein a single drive motor controls various fuel and combustion air linkages connected to a single shaft. And it's these linkages which can get out of calibration fairly easily over time, causing some pretty serious combustion issues, as seen in this picture, where we are not only wasting fuel because of unburned hydrocarbon, but we're fouling the heat transfer surfaces of the boiler and wasting energy out the stack because of a loss of heat transfer. Because, as you've heard many times, once you've benchmarked operating pressure, firing rate, and the ambient temperature in the boiler room, for every 40 degrees rise in stack temperature, you lose 1% in efficiency. So keeping those surfaces clean is very important. Now, the other area that we want to look at is where does the boiler spend most of its time, where does it fire most of the day? Now, as you can see in this slide, the sweet spot for most boilers is when they spend most of their time at 85% of their capacity or higher. Note that red arrow. And as you can see with the blue arrow, as the firing rate decreases, the lower the efficiency because of an increase in excess air. And that's exactly what you see in this curve. We are losing serious amounts of energy due to the excess air losses. And might I add a qualifier here? When we talk about excess air, It's the same as excess oxygen. It's just a difference in values, but they mean the same. And from an efficiency perspective, for every 2% increase in excess air or excess oxygen, we lose 1%. So what are the major causes for these high excess air losses? Well, they're an oversized boiler for the load, number one, and number two, a lack of burner turn down. Now, these both lead to excessive cycling losses because after each off cycle, the burner management system, the BMS, takes the boiler through its safety purges, blowing ambient air through the unit for over 2 minutes and cooling it down. And the other big impact area for efficiency loss is the amount of condensate being returned, or said another way, how much cold water makeup are you introducing to the system? And of course, to know that, you have to have a dedicated, accurate water meter. And then realize for every 10-degree increase in feed water temperature, you gain 1% in efficiency. So it's important to return that hot condensate. And lastly, as far as efficiency is concerned, for today at least, we need to look at electrical consumption as it relates to the motors on our boiler and supporting accessories. We often find considerable waste in this area, and I'll be addressing that shortly when we talk about solutions. Okay, so enough for the efficiency impact areas. Now let's look at where we find waste relating to reliability, and of course, its impact areas. And you know, we'll start with what I have found over the years to always indicate an unreliable boiler operation, one that is dirty, unkept, and disorganized. Now you can just bet reliability issues are going to be running rampant in this environment. Now that's in general, but if we begin focusing in more specifically, one of the main areas for reliability focus is the burner. And as you can see, a common trouble spot is the flame scanner. Now this is the device which sends a millivolt signal to the burner management system advising the presence of a strong pilot or main flame. And then failure in receiving this signal, the BMS, or the burner management system, will force the burner to shut down, and then it's got to be manually reset. Now, another area is the diffuser. Now, this is used to turbulate fuel and air for combustion. And this device can cause problematic combustion if the vanes you see here become compromised due to a flame front pullback, leading to overheating and distortion and cracking of the vanes. Smoke and soot is the result, leading to flame scanning issues, lockouts, and fouling of the fireside surfaces of the boiler, including possible plugging, as you see here. And by the way, the picture that you see here on the left is a natural gas-fired boiler. So, still zeroing in on the burner, the other area of concern will be, as mentioned, the fuel-air ratio control system. And again, here you see a single point positioning system with a single motor driving various linkages off a single horizontal jack shaft. Now, as this system ages and wears, it loosens and it deflects, causing combustion issues and flameouts, leading to nuisance shutdowns, amongst other things that I just showed you. Okay, now let's turn our attention to the boiler itself. And let's look inside the drum or the shell, if it's a fire tube boiler, because it is often here where we encounter reliability problems. Problems as indicated here in this boiler with the unstable water line. The issue is the unstable water level in the shell or the steam drum of the boiler as manifested in its low water cutoff and pump control. They're totally related. And as the level erratically bounces between a safe level, pump on, pump off, and low water, shutdowns occur, causing recycling and manual intervention if the auxiliary trips. Now, another reliability impact area is the insulating refractory in the boiler's furnace area, starting with the burner throat tile and then the oven liner. The problem is, if this throat and tile begin to crack and fall apart, it can cause combustion problems. And if the liner is compromised, well, possible overheating of the furnace, all leading to excessive downtime for repair and then expensive component replacement. Now, the throat tile I just showed you, it fits inside and around the steel burner housing. And if compromised, including its sealing, the housing can overheat, in which case the steel cracks leading to, the steel will crack, I should say, and leads to combustion problems. And again, unwanted downtime for both service and repair. All right, enough on reliability. Now let's take a look at safety. And of course, the impact areas associated with it. And you know, we'll start with electrical power awareness and the knowledge and respect that one needs when working around it, especially high voltage. But you know, make no mistake, low voltage can be dangerous too, and I'll talk about that a little bit later. But the main point now is that you make sure that you know where those electrical power sources are located in your boiler room. Next, you know, I'd be looking for hot surfaces, which if people are not aware can cause some painful and very dangerous burn injuries. Now, an example is this sight port on this wetback boiler access door. Or maybe the door itself can get pretty hot, just like the flange area on this dryback boiler's rear door. And the lower half of this door and its sight port get pretty warm too, even though the door has insulating refractory and the sight port, as you can see, has a cooling line. Remember, this half of the door is seeing temperatures well in excess of 1,000 degrees on the inside, so it gets pretty hot. And then there's what I consider to be really the most important safety devices on the boiler. The main low water cutoff pump control combination and the auxiliary low water cutoff. You know, we have to make sure they are in good working order. And the gauge glass, note the red arrow, is not etched or slightly cracked, because if it is, it can explode, sending shards of glass throughout the boiler room in addition to scalding steam and hot water. And you know, if the low water cutoffs fail and the boiler continues to fire because there's a load, this can happen. Not good. Now, another very important safety impact area is confined spaces where individuals are working. And if they are forgotten about and the space is closed and the boiler is allowed to come online, well, severe injury or death is imminent. And the last impact area I have on my list today as far as safety is concerned is the safety valve piping. We have to make sure it is correct so as to avoid any possibility of people in the boiler room getting scalded should that safety valve unexpectedly pop, allowing extremely hot effluent to enter the room. Okay, now let's focus our attention on the possible solutions for these impact areas as they relate to efficiency, reliability, and safety. And we'll begin, again, with efficiency and conserving the very high cost of fuel and electricity. You know, as simple as this may sound, we'll start by making sure the boiler is equipped with an accurate and easy-to-read stack thermometer installed in the boiler's vent outlet and monitoring it regularly. Because, as mentioned before, for each 40-degree rise in temperature above a benchmarked base firing rate, operating temperature or pressure, and ambient temperature, you lose 1% in efficiency. If you find a problem here, your boiler is fouled either on the fire side and or the water side, or it could be a flue gas directional baffle is compromised, allowing hot gases to bypass right directly into the stack. Those BTUs are not going into the water within the boiler. So you've got to take corrective action immediately, or it's just dollars out the stack, as you can see. Now, another big impact area compromising efficiency is a burner which is cycling many times an hour, and often it's in the double digits. I mean 15 20 times an hour, maybe more. This can cost in excess of 10 to 15% more in your fuel bill because of the pre- and post-purge losses mentioned earlier. So check this out. And if your boiler is cycling excessively, consider a smaller boiler, maybe new or used boiler, or adding high turn-down retrofit parts to your existing burner if it will accept them, or retrofit a high turn-down burner to your existing boiler to mitigate those cycling losses. Payback, believe me, can be substantial, depending upon how much the burner is cycling and, of course, the cost for fuel. Now, moving to the fuel and air delivery on the boiler. If you have a single-point positioning system, as previously alluded to, it is going to wear in time, causing slippage and deflection. Now, this throws off the proper fuel-air mix, wasting energy, as I mentioned earlier as well. So consider adding a parallel positioning system, replacing the rods and linkages with motorized actuators and a central controller for accurately metering fuel and air throughout the burner's turn down. Remember, an increase of 2% O2 or excess air equals a 1% loss in efficiency. These systems can pay for themselves very handily if the conditions are right. And when I spoke of maintaining the proper fuel-air ratio with parallel positioning control, you know, this may not be enough in certain situations because it does not account for conditions beyond our control, especially if they're extreme, because we may be losing efficiency here. The conditions I'm talking about are ambient temperature, relative humidity, and the barometric pressure. We have no control over that. Now, these can all vary dramatically and throw off the fuel-air ratio if the burner is not automatically compensating. And that's where the O2 trim system comes in and does this for us. Remember again, every 2% increase in O2 or excess air is a 1% loss. And staying with the thought of stack losses, here's another large energy saver possibility if the conditions are right: the boiler feed water stack economizer. Now, if your boiler is over 100 horsepower and you're operating at 100 pounds or higher, this should be a consideration, a serious consideration. Economizers can be either non-condensing or full condensing type, but in either case, they are preheating boiler feed water from the boiler's feed system and putting the additional heat from the stack into the boiler. Now, in the case of the full condensing unit, it has two sections, one for the boiler feed water and another section for a cold water supply from another source which requires heat. Remember, this flue gas is all useful energy which could be going into the boiler or some other useful purpose, but instead it's going up the stack if the economizer is not employed. Now, that said, this option needs to be rationalized, but where it applies, the savings potential can be dramatic. You know, I spoke earlier about makeup and the need to monitor this with a good water meter. Now, if you find you have a lot of clean condensate being lost, stop that and begin returning it to your boiler system, be it a DA or a vented receiver. And you know, if the condensate is high pressure, consider installing a high pressure condensate receiver to feed the boiler directly. Remember, it's preheated, it's already treated, it's been deaerated probably. And as mentioned before, the savings in many cases can be amazing. I mean early paybacks, and not based on simple payback or simple return, but I'll get into that a little bit later. Okay, enough about fuel losses. Now let's take a brief look at the electrical consumption on the boiler, and of course that takes us to the motors as noted earlier. And what I might quickly add, when we boiler manufacturers are designing our boiler packages, you know, we strive to apply the lowest horsepower motor that we can that will satisfy the need as efficiently as possible. Now, that may or may not include a high-efficiency motor, as this boiler business is really, it's quite price competitive. But, you know, I've noticed that specifications evolving over the years are increasingly calling for this option. So many boilers today are being equipped with this feature, albeit for an upcharge. But otherwise, consider retrofitting this as an option. Now, another option to be considered when looking at the motor impact area is for the combustion air fan in the feed pump motors to include a variable frequency drive. Now, this feature can reduce the electrical draw substantially when the boiler's combustion air fan and the feed pumps modulate as the demand for steam or hot water rises and falls. And as mentioned in previous webinars, variable frequency drives work in concert with a fluctuating demand, varying the speed of the motor simultaneously with that demand. Then as the speed of the motor is reduced, and remember this, when it's reduced, the power draw is reduced by its cube. So looking at the slide, if I didn't have variable speed control, the motor draw at 100% fixed speed would be 100% draw on the motor, regardless of my load. Now, when I apply the VFD and reduce the speed to match the firing rate, let's say at 70%, my electrical draw drops to 34%, and at 50% firing to 12.5%. So there's some real savings potential here. Okay, now let's turn our attention to some possible solutions relating to reliability and those impact areas that we highlighted previously. And you know, based on my personal experience over many years, when I think of what operations that I've encountered which were exceedingly reliable, you know, they look like this operation. But you know, that doesn't mean the boilers and facility were new or relatively new. On the contrary, they can be old like this boiler room. The telltale sign is that reliable operations are always neat and clean. And when you see a boiler room like this, I'm sure you'll also find well-organized files all nicely assembled and tabbed for easy access. And the one I have found to be especially helpful is the inspection file, because it will contain the various reports citing those impact areas I mentioned earlier, like the burner. You'll recall I mentioned the scanner, which is proving both pilot and main flames by sending a millivolt signal to the burner management system, or the programmer, or flame safeguard as it's sometimes referred to as. And the strength of this signal has to be in a specific range, and if it isn't, a lockout occurs. So any issues should be documented in the inspection report so corrective action can be taken as quickly as possible, as should any issues with the diffuser that I mentioned previously. Then there's another area with the burner that needs to be regularly inspected, documented, and maintained, and that's the burner's sealing and insulating refractories I pointed out earlier. Now, failure to do so results in extended outages due to noxious gas formation and overheating of the burner housing or furnace, causing weld cracking and the need for immediate repair or replacement. So it's just more downtime. I spoke earlier of another reliability impact area, and that's the low water cutoff. When it trips, caused by surging and dropping water lines in the boiler shell or the drum. Oftentimes, this can be traced back to a water treatment problem, which has gotten out of balance, requiring adjustment, or possibly contaminants coming back from the condensate return and may be caused from a process malfunction, such as a leaking heat exchanger. You know, the cause needs to be determined quickly and a remedy applied. All right, enough on possible solutions for reliability impact areas. Now let's turn our attention to the solutions for the major safety impact areas. And we'll start with possible burns caused by coming in contact, direct contact, with hot surfaces on the boiler. You'll remember I called your attention to the flange area on this rear door on the left, which gets very hot to the touch, as well as other portions of the door, especially the lower half. The first thought is to insulate the door to prevent personal injury. But you know, the fact is, insulating the door will actually cause interior door refractory and metal stressing problems, and ultimately a door failure. And that goes for the rear access door on a wetback boiler as well, as you see on the right. So, the best thing from a safety perspective is to place a warning sign on the door in those areas, calling people's attention to the potential hazard. Now, the other area that gets pretty hot, although not as hot as the rear door in a fire tube boiler, is the front of the boiler when the burner is a gun type, as you see here on the left, as opposed to an integral front head as pictured on the right, because in this case, the integral case, the front head is actually an air plenum, which keeps it relatively cool. So again, with the gun burner type, that burner boiler combination, I have seen where front doors are sometimes insulated to prevent burns as shown in this picture. But you know, I would hasten to add, you should always check with the boiler manufacturer before adding any insulation anywhere on the boiler to make sure it will not cause overheating and distortion problems and failure of that pressure vessel in some way. So far we've been looking at fire tube boilers as it relates to hot surfaces, which can cause severe burns, but you know, water tube boilers can be a problem in this area too. What you're looking at here is the downcomer on a high pressure steam flex tube boiler. Now, note how the pipe has been insulated to prevent possible burning of personnel. Now, I've seen many installations, though, where this is not the case, and this type of action should be taken. Now, the other thing I wanted to mention as it relates to safety impact areas and their solutions is the definite need for having good operating policies and procedures which highlight problem areas and instruct the personnel on how to prevent them from happening. For instance, the importance of having a strict procedure anytime a person enters a boiler's furnace or drum, as you see in these two pictures. The last thing you want is for anyone to be closed into that space, and God forbid the boiler be started or even left for an extended period of time. And that's why the policy and procedure manual will call for well-defined and strictly followed sets of rules that call attention to the warning and warning signs. Call attention to this by placing those warning signs in the confined area, and then a lockout-takeout procedure be enforced to prevent anyone from being severely injured or killed. And that goes for electrical safety procedures too. The high voltage areas need to be marked. A tag-out procedure has to be strictly enforced, including opening the main breaker. And also remember, low voltage is life-threatening too under the right circumstances, because it can cause heart fibrillation and ultimate death if the person is not tended to quickly enough. So as you all know, electricity, be it low or high voltage, is nothing to take lightly. Now, the other safety issue I often find in boiler rooms is the improper piping of the safety valve or valves in some cases. Remember, this is the final safety line if the high limit control on the boiler fails. It's there to relieve the pressure in the boiler before a water side explosion could occur. Therefore, it needs to be properly piped to the outside above the roof line. And this means the vent line has to be of ample diameter and supported to prevent damaging strain on the valve itself and to allow it to expel the hot effluent to the outside without injuring anyone. You know, I just hate to tell you how many times I have walked into a boiler room and seen these valves piped incorrectly, you know, even piped to relieve in the boiler room itself. Before I spoke of the records file found in organized and well-run boiler rooms, and as indicated, this file will contain the boiler room log, the document which contains all the important checkpoints on the boiler, which should be accurately documented on a daily, weekly, monthly, and annual basis. This, of course, along with the inspection file, are the key documents for keeping the boiler room not only more efficient and reliable, but much safer too. And again, I can't stress enough how important it is for the operating staff to take this seriously and accurately document the findings on a consistent and routine basis, not only for your own safety, but for all who are within the confines of that building as well. You saw that picture I showed you just before where a boiler left the building. Took a lot with it. And one of the most important safety tests is what we refer to as the evaporation test, making sure both the primary and the auxiliary low water cutoffs are properly functioning. Now to do this, you need to secure the boiler feed line, shut it off, and allow the boiler to naturally evaporate, steam off, without any makeup. And then watch the gauge glass very closely and make sure the burner shuts off at the proper low water level. If it does, then jumper the low water cutoff and allow the water to drop to the auxiliary low water trip level. And of course, any failure to trip any of these levels at the proper level means immediate burner shutdown and taking that boiler offline until that problem is fixed. Now, there is a primary low water cutoff on the market today which allows you to check the operation of the auxiliary without jumpering the primary and including many other safety features. But in any case, the evaporation test is the only true way of assuring the low water cutoff's proper functioning, and this test goes a long way in assuring safety in that boiler room. The last thing I wanted to mention about making the boiler room as safe as possible is the extreme importance of training. You know, knowledge is power, and that phrase really needs to resonate when it comes to being knowledgeable in the power plant because it impacts all three drivers, be it efficiency, reliability, or safety. And as you can see, there are many courses available for boiler operators and facility personnel to educate themselves on best operating procedures and practices in the boiler room, as well as how best to troubleshoot to keep that boiler online quickly or get it back online quickly, and also maintain the equipment in order to provide years of reliable service and to understand when it's best to call in an expert for service when the problem is beyond them or the boiler needs specific upgrades or a real fine tuning. All right, so there you have the main drivers of efficiency, reliability, and safety. We've discussed the various impact areas which most often affect them and the possible solutions for these impact areas. But how do we prioritize them once we have decided on a driver or two to address? Well, you know, my best advice when asked this question is to follow the money. Remember, we're talking about businesses here. In the common denominator, regardless if we're talking about efficiency, reliability, or even safety, is related to spending. What's it going to cost? And you know, how fast am I going to get my money back, right? Kind of sounds like Shark Tank if anybody's watched that. Remember, too, to justify a capital spend, you're normally vying with other departments for the limited funding available, so you need to have a story which goes beyond emotion and simple payback in order to get that approval. And that's where the mistake is often made, trying to justify the dollars with a simple payback. So my suggestion is to evaluate and then present the request based on net present value and internal rate of return. Because it is this type of financial overview which financial people in the organization can truly relate to. That's because net present value includes the time value of money and its opportunity, while also reflecting the monies in discounted form, which means we are comparing a dollar today with a dollar in the future. It will then reflect the cash flow for the investment, and if positive, will guarantee a very serious look at your recommendation. And then there's the internal rate of return, which includes the cost of capital and considers the company's tax rate. It also should be viewed against the company's hurdle rate, which is a fixed percentage of return the company expects before proceeding with any capital expense. And then finally, it uses this method to weigh the project and its positive impact against other projects vying for that limited capital appropriation dollar. So that, at least in my humble opinion, is how you would prioritize your particular request, be it for energy reliability or safety improvement. Look for the biggest impact for the company to save money and thereby generate more cash for the business. So you got to make it a win-win for everybody. Okay, here are what I would consider today's takeaways. Single-point positioning systems tend to wear, causing fuel-air ratio problems. 2% increase in O2 is a 1% loss in efficiency, so a parallel positioning system can remedy this problem. Keep that in mind. Excessive boiler cycling is a huge energy waster, so consider a smaller boiler or a high turn-down burner. That might be the answer. Be it a retrofit of high turn-down parts on an existing burner or a brand new burner. There could be excellent payback. Take a look at the net present value and the internal rate of return. Might be surprised. Reliability improvement starts with a clean and organized boiler room. Burner trips are mainly caused by fouled scanners and bouncing water lines due to improper water treatment or condensate fouling. Those trips will oftentimes require manual resets, and that boiler operator may not be in that boiler room. You could be down for a long time. Okay, the biggest contributors to unsafe boiler rooms are poor maintenance procedures and low water cutoff failures. Operator training is critical. You can do this online, you can do it in person, people will come to you. And they will tailor a program just for your operation, whether it be, and as far as Cleaver-Brooks is concerned, it doesn't matter if it's a Cleaver-Brooks boiler or not. Safety is safety, reliability is reliability, and efficiency savings are efficiency savings. Low voltage can kill. Don't take it lightly. Safe boiler rooms have excellent boiler room policies and procedures which are diligently followed, including documentation. And justifying a capital spend goes beyond the simple payback. That's where, you know, for years I made that mistake. I was trying to justify an economizer or whatever it might be, a blow-down heat recovery system, a high-pressure condensate return system, and I did it with simple payback. And I talked to a financial guy, and he gave me a blank look. He said, "You're not talking to me properly. I mean, how do I know you're going to hit the hurdle rate? You know, cash has an opportunity. There's other opportunities in this business, and other people are saying I can make more money or we can make more money if we put in that widget, not your blow-down heat recovery system." So I finally got smart after many years and started talking their language and had much more success. Okay, I think, Haley, it's time for some questions.